Hands-on projects and exercises. Building a language model using pre-trained models. Project overview. In this hands-on project, students will learn how to build a language model using pre-trained models such as GPT or BERT. They will fine-tune the pre-trained model on a specific dataset or task to customize its behavior for their application. Steps involved. Select pre-trained model. Choose a pre-trained language model suitable for the task. Consider factors such as model size, domain relevance, and availability of pre-trained weights. Data preparation. Pre-process and prepare the training data for fine-tuning. This may involve tokenization, data augmentation, and splitting into training, validation, and test sets. Model fine-tuning. Fine-tune the selected pre-trained model on the task-specific dataset using techniques such as transfer learning. Training and evaluation. Train the fine-tuned model on the training data and evaluate its performance on the validation set using appropriate metrics. Hyperparameter tuning. Experiment with different hyperparameters, e.g., learning rate, batch size, to optimize model performance. Testing and deployment. Test the fine-tuned model on the held-out test set to assess its generalization performance. Deploy the model in a real-world application if applicable. Exercises. Experiment with different pre-trained models and compare their performance on the task. Explore the impact of hyperparameters on model performance by conducting sensitivity analysis. Extend the project by incorporating additional data sources or fine-tuning strategies to further improve model performance. Fine-tuning a model for a specific task. Project overview. In this hands-on project, students will fine-tune a pre-trained language model for a specific natural language processing (NLP) task, such as sentiment analysis or named entity recognition. They will customize the pre-trained model to adapt it to the task's requirements and evaluate its performance on a benchmark dataset. Steps involved. Task definition. Choose a specific NLP task to focus on, such as sentiment analysis, text classification, or question answering. Select pre-trained model. Select a pre-trained language model suitable for the task based on its architecture, performance, and compatibility with the task. Data preparation. Prepare the task-specific dataset for fine-tuning, including data cleaning, tokenization, and splitting into training, validation, and test sets. Model configuration. Configure the pre-trained model for the target task by adding task-specific layers or modifying the model architecture if necessary. Fine-tuning. Fine-tune the pre-trained model on the task-specific dataset using transfer learning techniques. Training and evaluation. Train the fine-tuned model on the training data and evaluate its performance on the validation set using appropriate evaluation metrics. Hyperparameter tuning. Experiment with different hyperparameters to optimize model performance and generalization. Testing and deployment. Test the fine-tuned model on the held-out test set to assess its performance and deploy it in a real-world application if applicable. Exercises. Experiment with different pre-trained models and compare their performance on the task. Explore the impact of fine-tuning strategies, e.g., freezing versus updating pre-trained layers, on model performance. Extend the project by incorporating advanced techniques such as multitask learning or domain adaptation to improve model performance on the target task. Additional resources. Provide access to code repositories, tutorials, and documentation for implementing fine-tuning techniques using popular deep learning frameworks such as TensorFlow or PyTorch.